We have already seen the notions of the Bayesian networks and the Markov networks, and in this example, I'm going to present to you just a quick way to train a Bayesian network based on a defined structure you might have. So for the following example, we will treat nursery data. Basically, this nursery data comes from, I'll leave you here the link, and it's just a couple of variables to understand if if a couple of parents needs a nursery. The variables are displayed in this quick structure, which are the parents' occupation, if they already have a child's nursery, the form of the family, the number of children they already have, the housing condition, where they live, the financial standing, and the social health, which is the social and health condition of the family itself. However, for this example, this data set has been modified, and the reason behind that is because to train a Bayesian network, there isn't a lot of libraries to train Bayesian networks and to work with Bayesian networks. And the one that is right now like rising, as this is a method that is recently gaining a couple of followers, is called PGM, which is the following that is here. Oh, sorry. So PGM, it's not really old. It's actually quite new. It's made from Indian people. They have worked on it, and it's the more intuitive of the whole libraries that are currently in the PIP repository. So the general idea of this example will be with the modified dataset, which I will provide because you're going to use the same dataset for the lab, is to implement the following Bayesian network. So basically, here you can see the connection and the conditional probabilities. So children depends on the parents and the form of the family. This is the number of children. Housing, which is, if you can see from here, the housing conditions depends on the parents' status, which is I give you here a couple of examples, which is usual, pretentious, and great pretentious. So this is just a sample Bayesian network, which all the probability conditions goes to define if they need a nursery or they don't. In this example, this Bayesian network was defined randomly. So a person like me said, hey, I don't really know the data, but I think this network is going to provide the right conditional probability distribution so I can calculate if the person needs nursery or not. Also, one notation here is that the data from the data set came with names instead of numbers. To speed up the process a little bit and to make things more in terms of probability, I have moved this number. I have mapped all the names to a number. So basically, if the parent have a usual condition, it's 0. And for example, for health, we don't have a condition for the name 2. So the cardinality of health is just 2 here and nothing else there. So that's it. Well, the cardinality for social is 3 because they have no problems, early problems, or problematic. They can support even more cardinalities, but since this is going to take a couple of times just to get involved with the Bayesian network structure, it's better just to use a couple of examples. Normally, everybody treats for the first Bayesian networks binary examples, which is easier if you have the complete data to manually calculate the conditional probability distributions. But in this case, we won't bother with that. The library PGM will take care of it. So let's start working with this. Basically, we're going to need the 3 main libraries, which is NumPy, Pandas, and scikit-learn. And from PGI-Py, we're going to import Bayesian models. I went to a couple of troubles trying to run this, and the reason is because I have a couple of Python versions in my computer. The one that worked for me was the 3.65. Also, you need if you want to downgrade, just send me a message. I can provide you the couple of information. Also, the other thing is that I'm running on a Mac. Even so, Python is runs the same on a Mac or in a Windows. Just keep in mind that, for example, the Anaconda distribution might have different packages. Uh, I collected all information that bothered me when I was trying to run the PGM Pi. So these are the commands you need to update, and also the Python 3.65, because in this package it's not really supported by everyone. It doesn't really receive updates as soon as, I don't know, NumPy, for example. So I can give you here the packages you need to install. You might already have network, but just make sure you have the 1.1 version. So let's run this. And now let's construct the variation model. The nursery.csv file, which contains all the information. So what we're going to do right now is just to shuffle the data. We need to shuffle the data because the data already came really organized. So, for example, it was shuffled by parent. So you see that, for example, the first, I don't know, 1,000 records were for usual, and then the second 1,000 records were for pretentious. So we need to train our model with different types of parents, different types of forms, different types of number of children, and so on. So in this case, what we're going to do is we're going to shuffle the data. We're going to split the data. So the 75% is going to be for training, and the other 75% is going to be for testing. I left this random seed, so the shuffle is going to remain the same no matter times you run it, because in the lab we're going to validate with a different structure what is the difference between using the one I suggested, which comes from a person who doesn't really understand the data, and a second one who also comes from me, which is another person who doesn't really understand the data. So to construct the variation model is really simple, and this is the advantage of using PGM Pi. You just need to refer which is the parent and which is the children in the structure. So we see that parents goes there is a straight line, an arrow that goes to parents to housing and parents to children, and we can contrast this in the model. Let me just duplicate here so we can just switch between one and the other. So we see that, for example, form goes to children, and in the example, indeed, here forms go to children and form also goes to social. So basically, you just have to define those connections, and in a Bayesian network connection, we can have from a parent multiple levels below. But I mean, we can define all the arrows, but just but just by typing them here. So the Bayesian model will receive this list, which contains a pair of tuples. And in the end, after this is already defined, we just need to feed the data in order to train it. I'm gonna run this. The Bayesian model includes a lot of methods. One of the most important is to get the conditional probability distribution. If we run this, we have here all the relations we could find. For example, if we need the conditional probability distribution of parents, we assume that the parents is a random variable that doesn't depend on anybody else. We can print it here. Or for example, we need the housing given the values of the parents. Or I don't know, the most important one, which is nursery, depends on the social, finance, has nursery, and health. And this number here is the cardinality of the variable. As this gets bigger, also the conditional distribution probabilities will get bigger to understand. So for this example, let's just run the one which is the conditional probability distribution of housing given parents. And in this case, if I run this, we see that if we have a parent which is the parent 0, which is usual, we have a conditional probability distribution of getting housing zero of 0.28 given the parent zero. Just keep in mind that for all of these rows needs to sum 1, because that is the classical Bayesian conditional probability distribution. We can also print the data, which is a normal method of a data frame. You can see here what numbers they have, or if they are actually correct. For example, these here they just have, for example, for children it may be really confusing because 0 actually means that they have no children, that they have one children. But just to keep all the variables with the same structure from starting from 0, 2, and 1. So I decided just to use the same convention for children as well. Now let's take a look at how do we evaluate the data, the predicted class. In this case, the predicted class is nursery, which it can be 1, 0, and if we have more data, it can be 2 or whatever you want. So for this case, I'm going to take the data, which is the data, the test of the data, and I am going to assign it to nursery, which it will only remain the last column, which is, I mean, just to extract this column as a data frame. And from the test data, I am going to drop the column because that is the one I want to predict. So if I run this, I can have nursery, for example, which is just only the last column. And if I also go ahead and print the head, you can see here that the nursery is no longer part of my test data. So now let's predict using the predict function, which comes in the Bayesian model from the package. And finally, let's calculate the accuracy of the calculation. And to do so, I am just basically, since this is binary data, I can just go ahead and do a conditional and between the predicted values and the real values, which only will remain all that are the same and equals to 1. And then I just come here and divide it by the shape. And if they are equal, I mean, if both are 1, it returns true. If they both are 0, they returns true. And then I just divide it by the shape of 0, which is the number of rows or the number of the test cases. I am going to, I mean, we have been dealing the remaining 25% of the complete data set. We can see here that it has a final accuracy of 66%, which is, it depends. It depends if the data actually is correct, which I believe so, or if our model structure is the right one, because if not, we will probably need a different one, which is basically the lab of this example. So that's it for the example. If you have any questions, just let me know.